Hello, grade 10. How are you today? Today, we'll continue our lesson, chapter 9, lesson 3, the geometric sequences. We talked about the sequences and we said that the sequence is an ordered list of numbers. And we have two types of sequences, arithmetic and geometric. And for the arithmetic, we have a common difference, and for the geometric, we have a common ratio. And we said also, if I want to determine if this geometric is, if this sequence is geometric or not, by finding the ratio. If the ratio is common, it will be a geometric. If that's a common, it will be not geometric. Now, and also, we talked that we have two types of definitions that can I rewrite the geometric sequence with it, a recursive and an explicit. That the explicit that I need the first term only and the ratio that if I have the first term, I can find any term in the sequence. But the recursive, that's if I want to find the any term, I need the previous term, the term that comes before it. So a sub n is a sub n minus 1 times r. And also, for this problem here, I want to determine if this sequence is geometric or no. By what? What did we say? We said that we have to find the ratio. If the ratio is common, it is geometric. If it's not, it will be not geometric. And also we solved here in problem 2, how can we find an indicated terms? If they ask me to find a sub 100 as an example, I just need a sub 1. I just need also r, a sub 1 and r, the ratio to find a sub 100, sorry. Now let's do problem number 3 here. And problem number 3, how can we use a geometric sequence to find any term that I needed? Let's have an example here. Here there's a ball. This ball is bounces. The height of the consecutive bounces form a geometric sequence. What does it mean? That means it started with height, greater height like 5, then it would be 4, then it will be can say like 100, 50, 25, height is centimeter, 12.5, then 6.25, then 3.75, and so on. From here now, I want now to find the fourth term and the fourth and the fifth bounces. As in the sequence, we say we have first term, second term, third term, fourth term. Here we have first bounce, second bounce, third bounce, fourth, fifth, and so on. Let's start now with the first bounce, or we can name it with a sub 1. A sub 1 here is 100. A sub 2 is unknown. And a sub 3 is 49. So here we have a sub 1 and a sub 3, and he asked me to find a sub 4 and a sub 5. Now, if I want to find a sub 4, what did we say? We say it is a sub 1 times r, a1 times r raised to the power 4 minus 1. So a sub 4 is a sub 1 times r cubed. And a sub 5 is A1 times 5 minus 1 is 4. So to be 4 times r raised to the power 4. Now, after that, as you looked at A4, did I have the first term? Yes, it is 100. Now, did I have r? No. How can I find r? In the previous problems, we said that we can find r by dividing two terms that following each other. Two terms that they are consecutive. But here, as you see, do we have two terms that they are following each other? No. So what do you have to do? I mean, in the previous problem 1 or problem 2, if I ask you to find r, like if you have 4, 8, 16, 32, and if I ask you to find r, you just divide, you will say it is 2. 2. So it's very easy. So if I want to find the common ratio, I just divide the second term into the first term. But here, it's like, there's no two terms that are consecutive terms. I don't have, it's like this, 2, nothing here, then 8. From here, how can I find what r will be? I don't know how or what is the value of r, or I cannot find r. So what I have to do, let's have another equation. That's having it. A3 is a sub 1 times r raised to the power 3 minus 1. Is it right? Yes. Here I have a 3. I will say 3 minus 1. Then a sub 3, it is known. It is 49. Equal a1 is 100 times r squared. Now, 100 multiply by r. So I will divide by 100. I will divide by 100. So r squared is 49 over 100. I want only r. So what I have to do, I have to put under each term under square root. So r, it will be the square root of 49 over the square root of 100, which is 7 over 10. That's mean, as you see from here, r is 7 over 10. Now, if I have r now, can I find a sub 4 and a sub 5? Yes. Just here and here, I will evaluate, and I will tell you later on how it will be. But I will repeat. In this problem here, I have a1 and I have a3. He asked me to find a sub 4 and a sub 5. Okay, for a sub 4, as we said here, I need a sub 1 and I need r. I have a sub 1, but I don't have r. And r is a common ratio. This common ratio is become by dividing two consecutive terms by each other. But here there's no terms that they are following each other. So what I have to do, I will write another equation. Since I have a3, since I have a1, I can find r. a3 is 49, as we said. a1 is 100, and r, keep it as r, raised to the power 2, which is 3 minus 1. Then after I divide by 100, I will get r squared is equal 49 over 100. This is r squared. I want only r. So I can say, divide square root in each term, I will have 7 over 10. So R will be 7 over 10. This will be an ratio. Now after that, I have now to find A sub 4. A sub 4 is A sub 1, which is 100, times R, which is 7 over 10, raised to the power 3. 100 times 7 times 7 times 7 over 1000. And then 7 times 7 times 7. So now 7 times 7 times 7 is 343. Divide by 10, so it will be 34.3. This will be for A4. And I have to find now A sub 5. So A sub 5 is 100 from here times R, which is 7 over 10, but here now raised to the power 4. So it will be 100 times 7 raised to the power 4 is 2401 over 1 with 10 raised to the power 4. That's mean we have 4 zeros now. Then after I dividing it, it will be 24.01 centimeter. This will be now an A4, and here it will be A4, which is 34.3. And if you will continue, you will have that A5, it will be 24.01. This will be an A sub 5. So until now, we have two things. If I have A sub 1 and A sub 2, and they ask me to find A sub 100, it's very easy. I have A sub 1, and since A sub 1 and A sub 2 are consecutive, are following each other, I will say that I can find the common ratio. And also, so if I have two terms that they are consecutive, I can find the any term I want. But if I have like this one, A sub 1 and A sub 4, I need two equations because I need R. Now, in this problem later here now, if I have A sub 1 and A sub 3, and I need to find a term between them, what we have to do? Did you remember in the arithmetic sequence, we say that we have something, we call it an arithmetic mean? And the arithmetic mean, we say that it is x plus y over 2. Like if I have 3, nothing here, and 6, and I want you to find this term. What did you say? You say 3 plus 6 over 2, which is 4.5. So I can find this term here, which is 4.5. So the arithmetic mean, it helps me to find a term that comes between two terms like A1 and A3 or A2 and A4. And also we have a geometric mean. But the geometric mean, its formula is square root of x times y. Here it is x plus y over 2. But here I will multiply x times y, then the product of them under square root. Let's have an example. Using the geometric mean, if you have now these two, this sequence here, 48, any number, 3, And I want you now to find this missing number. How? I can find it by using the geometric mean, which is equal the square root of x. Here is x and here is y. So x times y. Where is x? It is 48 times y, which is a 3. Now, 48 times 3, it is 144. So, the square root then of 144, it will be positive or negative 12. Now, why you say it is positive or negative, not only positive 12? Because now here, you have to know something, that if I asked you square root of 4, you tell me it is 2. But if I told you that if x is square root of 4, if I have variable now, okay, this one, if x is 4, you can say now, because it's variable, so it will be positive or negative 2. Okay, if I have now y is equal square root of 16, you will say it is positive or negative 4. Now, and so here now we have the same. The geometric mean, as we name it the z. They are square root of 144, so the answer will be positive or negative 12. So by now, I can say now the answer here is C. So the geometric mean, it will be, as an example, let's have another example here. For this one, I have some list of numbers, I don't know it, but he told me that a sub 9 is 45 and a sub 10 is unknown and a sub 11 is 80. He wants now to find a sub 10. Now, a sub 10, it will be. Now, we said that this is a geometric. Because of that, because it's a geometric sequence, so I will name this term with x and this term with y. And the geometric sequence is the square root of x times y. So it will be square root of 35 times 80. This will be a sub 10. Then 48 times 80, it is 3,600. So what will be a sub 10? As I told you, if I have x equal square root of number, so because of that, I can say that a sub 10 is, what is the square root of 3,600? It will be positive or negative 60. So here, because of that, we have two possible sequence. It could be 45. Here, since we find that there are two numbers it could be, so here it could be positive 60 and here it could be negative 60. So here we have a sub 9, here we have a sub 11, and I need to find a sub 10. They are at this term that they are coming between them. How can I find it? By using the arithmetic, the geometric mean. The geometric mean, it says that if I want to find any term, I just multiply the previous term, multiply by the second term under square root. Now, before solving this problem, I want you now to summarize some ideas. If you have a sub 1 and a sub 2 and a sub 3 as an example, and if I asked you to find a sub 1, you just need a sub 1, which is known, times r, which is also, it's very easy to find by dividing a sub 2 over a sub 1. So you can find r, you can find a sub 1, and you can find, because of that, any term that he asked me to find it. But if I have a sub 1 and a sub 3 only, and a sub 2 is unknown, here I need to find a sub 100. To find a of sub 100, I need a1 times r. a1 is known, but r is unknown. To find r now, here, in the previous one, we said that r, I can find it by dividing a sub 2 over a sub 1. But here, there's no terms that are following each other. So how can I find r? By using another equation that says a sub 3 is a sub 1 times r raised to the power 2. Then a sub 1 is known, a sub 3 is known, so I can find r. Is it clear now? Here, if two terms they are following each other, I can find r. But if two terms they gave me as an example a sub 1 and a sub 3, and he asked me to find a sub 100, I will use this formula. But if I have a sub 1 and a sub 3, and he asked me to find a sub 2, here it's very easy. I just use the geometric mean. That's, here is x, here is y. I just multiply x times y, then the product of them under square root, and the answer, it could be positive or negative number. Now, let's do this problem here. When radicative substances decay, the amount remaining will form a geometric sequence when measured over constant intervals at time. Here, he showed me the amount of neptunium that initially it is 1,244 grams. After 1 hour, it is unknown. After 2 hours, it is 346. After 3 hours, it is unknown. And after 4 hours, it's also unknown. Now, he asked me to find a sub 1. So a sub 1 is known, which is at 0, a sub 2, a sub 3, a sub 4, and a sub 5. Now let's make it as a table. Sorry. Now, a sub 1, it is 1,044, and a sub 3, it is 304. Sorry. After 2 hours, I name it with 346. Now, I want to find a sub 2. I told you that if I have a sub 1 and a sub 3, and I need to find any term that they are coming between them, I just use the geometric mean. The geometric mean, which is to find a sub 2, is the square root of x times y. That means the first term times the third term, which is equal square root of 1,244 times 346. Then the answer is 656. And don't forget here, you have to write. Okay, here now we have positive and negative. because I told you that if I have a sub 2 equal number, the answer could be positive and negative. But because here he told me that it's a grams, it is a mass, and the mass cannot be negative, so the answer will be only positive 656. So by that, I can find now a sub 2, which is 656. Now, I need a sub 4. Look at here. If I want to find a sub 4, I just say it is a sub 1 times r raised to the power 3. How can I find a1? It is 1224. Then r. How can I find r? How can I find the common ratio? By dividing two terms that come following each other. So if you divide a sub 2 over a sub 1, that means 656 over 1244. The answer is, or r is 0.52. So r here is 0.52 raised to the power 3. Then a sub 4 it will be 174.9 grams. So here the answer is 174.9. And also, if I ask now, or if I want now to find a sub 5, I will say it is a sub 1 times r raised to the power 4. This is a way. Another way, I can say that also that a sub 5 is a sub 4 times r. Now a sub 4, which is 174 times 9, multiplying by 0.52, and the answer is 90.95. This will be now a sub 5. Now, in this one here, they asked me to find an explicit formula and an explicit formula for each sequence and write the first 5 terms. A sub, let's find number 33. Number 33 here, I have a sub 1 is 100 and r is negative 20. He asked me now to write an explicit formula. What the explicit formula will be, a sub n is a sub 1 times r raised to the power n minus 1. So 100 times negative 20 and negative 20 only raised to the power n minus 1. This will be now an explicit formula. This is a sub 1, which is known as 100, and r, it is negative 20, and r only is raised to the power n minus 1. Now, if I ask you now to find a sub 2 as an example, what did you say? You say it is a 100 times negative 20 raised to the power 2 minus 1, which is 1. 100 times negative 20, so it is negative 2000. This is a sub 2. Then a sub 3 is a sub 1, which is 100 times negative 20 raised to the power 2, because it's 3 minus 1, 2, which will be 100 times 400. That's negative 20 raised to the power 2 is 400, and the answer will be 40,000. Now, a sub 5, sub 4 will be a sub 1, or we can name it as 100 times negative 20 raised to the power 3. Now, negative 20 raised to the power 3 is negative 8,000 times 100. The answer is negative 1, 2, 3, 4, 5 zeros, 8, which is 80,000. So by now I can find, by finding the explicit formula, I have a sub 1, it is 100, a sub 2, it is negative 2,000, a sub 3, it is 40,000, and a sub 4, it is 800,000. This is how can I find the first 5 terms by finding the explicit formula. And if I want to write the explicit formula, I just need R and the first term. Then I can write now the explicit formula. Now, finding the missing terms of each geometric sequence. Here, in number 45, as an example, let's find 45. In number 45 here, we have 2.5. We have a missing term, another missing term. Then 202.5. For this one here. Now, in the previous, I told you before that if I have A1 or A sub 1 and A sub 2, I can find R. If I have A sub 1 and A sub 3, I can find A sub 2 by finding, here as an example, if I asked me to find A sub 2, I used a geometric sequence that says the square root of x times y. What about now if I have A sub 1, as you see here we have A sub 1 and A sub 5. How can I find A sub 2, A sub 3, and A sub 4? As we said in the arithmetic sequence, that if I have to find A sub 5, A sub 3, I just add A sub 5 plus A sub 1, divide by 2. And here also in the geometric sequence, you have to do the same. But if you want to find A sub 3, you don't add them, divide by 2, like the average. You just say, I have to say the square root of A sub 1 times A sub 5. By now, if I have multiplied A sub 1 times A sub 5, the product of them, and their square root, I will find A sub 3. So A sub 3 will be 2.5 times 202.5. If you're multiplying them, you will find that the answer is square root of 506.25. This will be A sub 3. This is a scope. Square root A sub 3 is a square root of 506.25. So what is the value of A sub 3? It will be positive or negative 22.5. So positive or negative 20, So here it will be positive or negative 22.5. This is now I find A sub 3. Now what about A sub 2? Now it will be a very easy. Why? Because if I want now to find A sub 3, A sub 2, if I have A sub 1 and now if I have A sub 1 and A sub 3, I can find A sub 2 by also use the geometric mean. So A sub 2 is the square root of A sub 1 times A sub 3, which is 22.5 times 2.5, which is 56.25. This will be now a sub 2. Then a sub 2 is the square root of 56.25, which is 7.5 positive negative. So a sub 2 is positive negative 7.5. Now what about the last one here? And the last one now, I ask you now to find a sub 4. To find a sub 4, I just multiply a sub 3 by a sub 5 under the square root. I will get a sub 4 by using the geometric mean. Because so a sub 4 is the geometric mean of a sub 3 times a sub 5. A sub 3 is 22.5 times 202.5 it will be square root of 4,556.2. The answer will be 67.5. So from here I found that the answer is 67.5. This will be now and missing terms A2, A sub 3, and A sub 4. I want you now to solve number 46 and send me the answer on as an email, on Nicholas email. Now, in this one here, if he told me that a sub 5 is 112, and a sub 7 is 448, he asked me now to find a sub 1. Okay, a sub 1. Let's use the first equation. A sub 5 is a sub 1 times r raised to the power 4. How can I find a sub 1? But r is also unknown here. So a sub 5 is 12 equal a times r raised to the power 4. Let's use now a sub 7. For a sub 7, it is a1 times r raised to the power 7 minus 1, which is 6. So a sub 7 is 448 equal a times r raised to the power 6. By now here, I have to find a sub 1. To find a sub 1, I need r also. So how many unknown here? We have two unknowns, a sub 1 and r. Two unknowns, that's mean two equations. Now, if you dividing them, let's divide this one into this one. Here we have two equations. Now I want to solve them. Why two equations? Because I have two unknowns, a sub 1 and r. Two unknowns, a and r. So I need two equations. So and the other now is 12. If you're dividing them, a over a, it's cancel each other. Now 448 divided by 12 is It's not 12, it's 112. I'm sorry. It is 4. So 4 is equal. Then here, r sub 6. R raised to 6 over r raised to 4. It's dividing, so it will be subtracting. The powers will be subtracting because we have the same base. So r squared is 4. So r is equal to 2. Now, so r here is positive or negative 2. If I have now r, which is 2, let's evaluating in one of the equations. This here now. Why? I have, let's go back to one of the equation. 112 equal a times r, which is 2 raised to the power 4. Even you put 2 or negative 2, you will get the same answer. Now let's go back to this equation as an example here. For this example, a sub 1, I need it, but I have now r. So here I have now one unknown, 2 raised to the power 4 is 16. A equal 112. Divide by 16. Divide by 16. So A now is 112 over 16. And the answer is 7. So this is the value of A, which is 7. Let's do now number 62. In number 62 here, we have A sub 9, which is half, and A sub 12, which is 1 over 16. I need A sub 1. To find A sub here, we don't know R and A. So since we don't know A and R, we don't have, I mean that we have two unknown equations. Two unknown values, that means that I need two equations. How can I find these two equations? The first one from A sub 9. And the second one from A sub 12. Now, A sub 9, we say that it is 1 over 2. A times r raised to the power 8. This is my first equation. We'll name it with equation number 1. And here now, A sub 12 is 1 over 16 equal A times r raised to the power 11. And we will name it now with equation number 2. So now I will repeat. Here I have to find A sub 1. If I want to find A sub 1, and also I need R. So how many unknown here? We have two unknowns, A1 and R. If we don't, because of that, we have two unknown, two variables. If I want to find them, I need two equations. From where I bring these two equations, from A sub 9, I can find the first equation, and from A sub 12, I can find the second equation. As you see here, after we find them, here we have A sub 1, and here we have also A sub 12, is equation 1 and equation 2. Let's now dividing equation 1 into equation 2 into 1. 1 over 16 equal A, and 1 over 2 let's now dividing them, cancel each other. Now here it comes like 1 over 16 dividing by half. You can see it's multiplying by its reciprocal, so it is 1 over 8. Why? Because if you divide fraction by fraction, you will keep the first fraction as it is, then the divide, keep it as multiply, then the reciprocal of 1 over 2 is 2 over 1. So what is 1 over 8 equal r, and here we have two bases that they are divided. I will subtract the powers, so it is r cubed. Then cube root, so the value of r here is 1 over 2. After I find r, which is 1 over 2, let's evaluate now in this one here, in the first one as an example. Half equal a times r, which is 1 over 2 raised to the power 8. Solving. Now, half is equal to a times 1 over, I will distribute the 8 into 1 and 2. So 2 raised to the power 8 is 256. Now a is multiplying by 1 over 256. So let's dividing them, or another way, let's multiply by the reciprocal of 125 here and here also. After multiplying them, you will find that it is 256 multiplying by half is equal to a. Here I multiply 256 by the term from the right and the left term. From the right term, 256 multiplying by half, and from the second term, a times 1 over 256 times 256, it cancel each other. So it will be now 128. This is the value of a. Here I will repeat what I did. Let's have another example. If you have 1 over 4 is equal to a times 2 over 3. What did we use? How can we find a? By dividing into 2 over 3 into 2 over 3. Now, if you divide, because you're dividing them by the same number, it will cancel each other. Here we have a. Now here, if you have fraction, divide by another fraction. What did you say? I will keep the first fraction as it is, then I will change the divide into be multiply, and I will write the reciprocal of the fraction. So here we have to do the same. Let's keep 1 over 4 as it is, times the reciprocal of 2 over 3 is 3 over 2. And the answer will be 3 over 8. So this is the value of a. Here is the same. Here we have 1 over 2 equal to a times 1 over 256. If I multiplied any number with a and I want to cancel them, I just dividing them. So a now is, keep the first fraction as it is, multiply by the reciprocal of 1 over 256, which will be 256 over 1. Then by multiplying them, or by simplifying them, you can say that the value of a is 128. This will be our lesson geometric sequence. Thank you for listening.